And so, thank you for being here. It's a pleasure for me to give this presentation in this nice context. I love this conference. I have already been in Russia one time this year in CodeFest. It was amazing. And I just had the occasion, thanks to Dimitri, to visit the city. It's really awesome. I never been here, so it was mind-blowing. So thank you for your city, for being here, for discussing also right after the session with me all the details, because I want to brainstorm with you. I want to hear from you the questions. And let's go straight to the point. I am Raffaele Rialdi, a long-time MVP, of course, not a football player, but Microsoft MVP. Okay, I'm a trainer, a consultant. I give speeches in different conferences. And also, you can see about security, yes. I love to tell a story about security, starting from the attacker perspective, of course. And so, but this is not the case for today, but it was really nice. I traveled in a lot of countries, especially this year that I jumped from US in Ignite, Microsoft Ignite, from Europe in Romania in a few days. And I am happy to code. That's my being. So basically, my hobby is coding. Yes, my job is coding. I am a pretty boring guy, but I love to tell stories to people that loves programming. So let's go straight to the point. Code generation, what is that? Code generation means that I want to gain performance, but I don't want to show you any benchmark here, because it would be a trick, a nasty trick. Showing benchmark is something that you have to avoid on stage, not because it's dangerous for the speaker, but just because it's just a little use case that probably doesn't cover all the audience. So it's up to you to try the techniques and to see if you have a gain in that specific use case that you have in your product. So benchmarks are not that really important. I did it for myself, and I had good results, but I have to say that it's not that relevant in this moment. We know that reflection is slow, by definition. But it's not something that we can complain, because if you see how reflection works, it's pretty obvious. You have to load the ECMA 335 metadata. You have to interpret that. It's a very compact binary amount of data that is tricky to expand, and is compact for obvious reasons, and we don't want to take too much memory in our assemblies. And once you exploded these artifacts, you happen to be disappointed with the performance because it's a very low-level API. By the way, you can avoid the reflection and straight load all these artifacts directly from the assembly. And if you are interested into this, is not covered in my session, but I already did it to avoid loading permanently an assembly in memory, but I can unload it and still have type information. When we should generate the code, we want to generate the code at a certain point of time in the life cycle of our application, when we have enough information that are relevant to reduce the complexity of our code, of our algorithm. For example, we can grab some information from the user interface about a filter to reduce the number of records getting from the database. Or maybe you have other information that came from the types that are loaded inside a plugin. So many things can happen in the life cycle of your application, and you want to take advantage of that. But you don't want to spend time in making the sort of generic algorithm that have to take in consideration anything and use reflection because I want to build the most generic algorithm possible. And by the way, we know that developers have this strange habit that once they begin to do, I made an addition, they want to create an algorithm that made addition on anything. So strings, integer, or orders, or whatever. I invented a new algorithm that is generic and works for everything. No, it's something that comes in our mind every time we begin and working in something. The idea here is exactly the opposite. It's just to patiently wait and say, I want to wait that I have enough information so that I can generate the code that is needed to do the less code as possible, to put in memory the less amount of code as possible. And what I can do with code generation? Well, what are the problems that I'm going to resolve? For example, link predicates. The predicate builders are something that are out there since a long time. Then maybe formulas like the one in Excel. Maybe types, as I said, loaded from a plugin, you want to express something. Maybe also something else that if you are familiar with reactive extension. How many of you knows the reactive extensions? It's a very nice library that allows you to grow the stream of data of events and apply these expressions that can filter groups, then can elaborate, transform the data, these streaming events, and modify in many ways. And they use the expressions. So we will see many of these examples just to see what can happen. We will start from expressions. And this is just a sample, very simple example on how we can create a console write line. Maybe many of you are familiar with this. It's simply, I have to use reflection. You say, why are you using a reflection? Well, you just said it. You don't want to use reflection. The problem is not just not using reflection at all, but moving the hot path out, moving the code generation, moving the things out of the hot path. So I want to find a point in time where I can use these tools like reflection to grab the needed amount of data to generate the code, and then inside, for example, a loop, I want to just use a straight delegate to avoid the mess of waiting that the code is executed. So I first take the exact overload of the write line, then I create a parameter that will be the input message, then I create the equivalent of the method call. Null is for a static method, because console write line is a static method. I have to specify the method info, the reflection method info, very simple. And finally, the parameter that will accept the message. That's it. Once you have that, you create a lambda. And to create a lambda, it's very simple because you have to specify the parameters and the block, the body of the lambda. That's it. Once you have the lambda, finally you have this very, very useful compile method. What does this compile method do? The compile method is very useful because it directly creates the instruction in memory in a very, very simple way. We don't have source code. We don't have anything that we have to process from the Dragon's Book perspective, okay? We don't have to make the first step of the compilation, that is parsing the stuff, understanding the text, spend a lot of amount of time in understanding what this text means for us. We already know with an expression that is syntactically correct. And that's extremely important. This is why the expression tree is so hard. It's strongly typed in a very annoying way. If you already tried to put together many expressions, you know how annoying can be building an expression. And once you have that, You can compile because it's just taking the nodes that are represented by the expression and creating the matching that is the corresponding code that we want to call. So we finally have a delegate. And once we have a delegate, we are done. Because the delegate is the fastest tool that we have to execute some code. For example, to create a predicate that is a very simple function that takes an arbitrary input, in this our example is an integer, and returns a Boolean, so that every time we process a list of integer, for example, we can say yes, no, yes, no, yes, no, and we had the odd number, for example, okay? So to create a predicate, I can create a parameter that is the input one. This name x is something that is only for debugging purposes, and you don't have to care too much. Left is the left of the operation, so this x. And then the right is the negation of 10, okay? So this is an unary expression, and is of type integer. And finally, we create with this left and right by binary that is represents the comparison. So there is nothing special again. Finally, we can return the expression lambda. And it's better to return the expression lambda instead of the delegate in this moment, because if we still need to make some change, if we still need to elaborate something else inside, we can still do it. So we can use visitors that is not like the telefilm of many years ago, it's visitors coming from the external space. Visitors are something that enumerates all the nodes that are inside the expression and can be used to modify the expression in a very precise way. So it's not like managing text. You go straight to the node that is representing exactly the node that you wish. So for example, if you want to visit a call, say you are grabbing some predicate from the where node because you wrote this stuff on link, you want to visit this expression, and once you have the expression with the predicate, you can visit, and you just find it because the where is a call to an extension method, of course. If it's a call whose the first parameter of the where is the iQueryable. It's an iQueryable of t. And it returns a Boolean. So we also know very well which is the shape. And if you want to modify something inside this expression, you have the chance to do inside these triple dots. That's it. So let's go and see some example, because things are getting quite boring. I created, and this was not my intention at the very first site, because, writing a parser is something that it's boring. It's probably slow, because there are generic libraries that makes this stuff better than what I can do with writing a few lines of code. And but it's not self-contained. I really wanted something that was very small, very handy to modify. Instead, if you reference the usual parsers, you end up in creating the grammar and having to reference a lot of the DLLs and so on. So I really wanted, I want something that I can modify at my will. And also because I want to give a shape to the parser so that the generated nodes after the parsing are pretty similar to what the expression can express, so that the mapping is similar. And what I did is, what about if I express this x plus y, y in text, and I recognize them? I wanted to express manually the parameters. It's a matter of simplicity. Probably it's possible to avoid that, but it's important at least to specify the types. This is important. This is very important, because in the expression, we don't get benefit from the first part of the compiler, so the first step of the compiling process. So We don't have, for example, automatic type conversion. We don't have implicit type conversion. There is no transformation between a double, between an integer to a double. There is not. You have to do by yourself. And this is the reason why I wanted to do that stuff. If you run this code, you receive basically an expression back. And that's pretty simple because you have this parse result and you have the expression. And you have this weird way the lambda is expressed inside the debug view of Visual Studio. It's not something very nice to see, but I have to say, OK, I can live with it. It's not that difficult. It's a basic x plus y, so I can live with it. And I can go on, and I see that f1 is this method. I am not executing it because you can imagine I have tons of tests running this stuff. And this is very funny because when I was at school, I always dreamed to put a function in text and draw my graphs and so on. No, there was the very first PC. I began with the ZX81, so it's a very long story. But they are pretty good. And let's see how I could translate this sum. This is my function, of course. It's not something that you want that really exists, but I defined a function helper with a predefined function, basically as much as Excel also do, because these applications need to predefine a sort of dictionary of functions. And this is pretty easy. So I pass an array of elements, and these are doubles, and make the sum, and blah, blah, blah. But let's go a step further. So I have another function that is getFilter. This getFilter, as you can see, is a lambda. Normally, you would return directly in a func of int, comma, bool, and nothing else. But there is a special feature of the compiler that if your function, inside the body of your function, does not contain any bracket, okay, so it's kind of simple in a single expression, you can return instead an expression of a func of int, comma, bool. And you gain automatically the expression for that representation. And that's very practical because you can still modify it. So if instead you want to take away the number and replace with something else, you just visit the expression and make the kind of modifications that you want. OK? After this, what I want to do, I say, OK, I have this predicate, but I want to modify not just for changing numbers, but I want to inject something inside so that when it's true or when it's false, I want also to debug with the console write line. And so in my injector, that I will show you in a second, I pass the predicates, and then I pass two lambdas, and say every time you receive this value, please print with yes or print with no, because if you remember, this is just the odd function. And basically what you have here is a more complex function that has an if. So I modified quite heavily, if you want, the expression. And I said, OK, I have an integer in input, and then I injected the if, and I write the console yes or not, depending on the value, and then I finally return the value that I processed with the expression. So it's pretty common to do these kind of modifications, and they are very powerful. You see that as soon as we go on, there is a problem. This kind of visualization is weird. So if you want to give to a developer team this kind of information, well, it's not that good. I mean, programming with expression give you some advantage, but also from developer's perspective, it's kind of messy. I mean, it's definitely not something that we want to see. But this is the world of code generation. So basically, what we have here is that I have, and you'd remember the laziness. So until we enumerate all the numbers, we will not execute the stuff that is behind. So by pressing F10 here, I basically have all the list with also the console write line that is invoked automatically for this behavior. Okay? Well, you may say, okay, everything is very nice, but I would like to do something more sophisticated with that, because it's not something that I like too much. So I had a kind of nightmare, pardon, a dream, you know, the developers. And they said, okay, let's see this kind of strange thing. So I want to build a Lambda. We will see in a minute how it is. I want to build a Lambda that, once compiled, transform this data in a dictionary, maybe a JSON, okay, in an order. It's something quite common, right? And you may think to that as, let me show you this code. If you had to do this code with reflection, this will be the result. So basically, you have to iterate the properties under reflection and to see if there is a matching entry inside the dictionary, and in this case, copy it. We all know that is slow. I mean, at least if we do this stuff just once, it's not a problem. If we do this stuff 1 million times, well, let's talk about it. If we do it in a server application that is consuming resources on the server, well, probably someone is going to be upset, okay? So the second thing that we can do is create this code. That is, I want to map an order, and I have this dictionary, and I want to obtain an order, so I begin writing the new order, and then I extract the values that are object, of course, and then I casted all the things, and I copy the value. It's pretty boring. I mean, it's something terrible, right? It's something that I don't want to do. So the idea is, what if I create a Lambda that knows the order? And this is an important detail. I specify the type of order, and not of T. I could put an order with the angular bracket. That will be nice, of course. But what if we don't know the order? What if the order is defined in a plugin, and we are delay loading this plugin? It's a problem. So the important thing is to think about using generics in certain time. In this case, it will be not the perfect solution, because potentially we can need to stay without this information. And so we want to compile. I will come with the debug compile in a second. Okay. It will take a while because of the debug thing. And then I create a dictionary, and finally have the Y, that is the copied valued. What is that? And this is going to be quite weird, because, you know, you like it, right? It's so nice to read this code. This is the code we wrote using expression. And how is the expression created? So let's go back for a moment, and let's see the expression generator. And if we, or at least we can press F12 so that I go straight to the point. And you see that it's pretty similar to the one that I wrote with the reflection. So I defined the parameter, I defined the variable with the result, I created an expression with the new of the object, the activator create instance stuff. Then I assigned the new instance to this variable. It's boring, I mean. And then I get the method, I iterate with the properties, and instead generating a loop, because it doesn't make sense. We already know how many properties are there, so we can loop unroll all the thing and write exactly what we have in this moment. And I generate exactly the calls that are needed to extract the try get value and then the convert, which is the cast is necessary, of course, because types can be quite different. There is an object. And then the make access member it is to access the property value and the if then for the try catch. Finally, I create a block, which is an open and closed bracket. And now we have the lambda. Oh, it's so nice. So I decided to create a sorcerer, a kind of wizard. And if you take this code, and then I go to the visualizers, I copy this stuff here, and I repeat the operation of debugging. And I go here, and I say, OK, I want to see my lambda, but now I have a nice visualizer. I open this guy, and you see that it's pretty bad. I mean, you still have a tree. But this is very useful when you are poking with yourself in memory, because it's something that you look at yourself at the mirror and say, what the hell I am writing here? And so, yes, we talk with ourselves. Yes, it's true. And so, OK. And then you have all the parameters here. It's pretty good, this, because I want to quickly switch from one leaf to another and see the values, the types, and so on. So this is practical. But even better, wow. This is the code that I would have written if I knew the information that I passed to the code generation at the time that it ran. OK? I never wrote this code. It's pretty similar to the one that I show you, but this was generated on the fly, and I didn't even generate the C#. I generated the expression, so I had only syntax nodes in memory. I never had this stuff. So what I had to do, I had to decompile it. And thanks to Roslyn, I also have the colorization. So I also have the colors. I can improve the colors, if you will. If I can, it's my own colorizer, so I can modify also the colors if you want. And I added this debuggable attribute because I don't want optimizations that may arise from the compilation itself. And you know why? Because I have another surprise for you. So once we do not compile, but we debug compile, we press F11, and we enter the method that we never wrote. Is that cool? So you are debugging with the source code something that you never had the source code. And basically, this means that once you go on, you can see the actual values. And you can check if you made some mistakes inside your expression. You see, description is not there, so the try-get value was really needed. And finally, I have the order with the correct number of values that is out there. So basically, what we have a lot of things there, because the expressions cover almost all the language. So you can create if, throw, catch. You can create complex things. But you probably need some tool to do that. In the parser that I wrote, I had the most difficult part, and I want to bring you my experience in that, is creating the implicit conversions of the types. Because if you try to make an X that is a double, and you want to assign it with an integer, you will receive an invalid cast exception. And the reason why you have that, because this implicit conversion is made by the compiler. But we didn't have the compiler. And so simply we have to generate the stuff that the compiler normally does for you. That's it. I also have a few other things that if you want to see more complex expressions, for example, this is a very simple object. Okay, if you want to see how a new is created, for example, and this expression is built by taking. Okay, I always suggest to use the type of for the reasons that I told you before. Then I take the constructor. I need to take the exact one, of course. Then I need the various methods that we'll use in this demo. And once I have the call, I need to build a new object passing the constructor information, and then I can call it and so on. There are more. I mean, I don't want to bother you with each of that, and if you need more explanation, I will be more than glad to show you right after. I just press a few. I want to show you like how an expression looks like when you assign the property. Okay, this is the compiling artifact, but basically, if we go to see the real expression, it's this mess, okay? Sorry, this is the zooming. So you have to do a few things. And one of the most complex that I generated is for marshalling things. So I generated some code that allows me to make an asynchronous code to an add async, even if there is no code that is able in the expression to represent the task of T. This is quite messy, because first of all, this code cannot be recompiled again, because the compiler that is monosessil is not able to create still today, but maybe in the future, the perfect decompilation. So there is still some issues from the monosessil perspective. Second, the problem is that I have to inject an external function to deal with the task and to make the continuation of the task of T, because the expressions were created before the asynchronous libraries and the changes that the compiler did to support async await. And so you don't have the chance to generate with the compiler an await on your own. And you know that the compiler does the magic. So if you take ILSpy and look at the artifact created with the await, you have really a callback with a continuation. So it's something that is very, very complex from this perspective. I will be more than happy to show you the details later on, if you will. Okay. So basically, where are we? We created expressions to make certain kind of predicates, functions. We can create also quite complex pieces of code with if then else. Okay, so we can throw exception, we can catch exceptions, we can do a lot of things. But what about Roslyn? Roslyn is the .NET compiler platform, is the new compiler that from quite a few years we have as our main C# compiler. Okay, it's the one that rules our world. Roslyn opened the API to us. So we now can, directly using the API of the compiler, to do a lot of things. And we have, for example, the formatting. We have symbolic information. We have the availability of compiling the stuff to also interpret the symbols to enter the metadata that is behind your assembly and much other. The colorization in reality is not something that is really given from Roslyn. So Roslyn will never tell you should be in green or in blue. It's just because there is a classification of the tokens that are parsed, and so it's up to you then to render this stuff in a color or in another. Of course, in this way, everything is covered, but there is a problem. So even if we have a lot of tools, blah, 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 of the slide, we are strong typed. So there are syntax nodes, okay? And that are very easy to use because everything is a syntax node. So you can put all together. You don't have the mess to be very, very careful to put one syntax node on another. But you pay a price for this. Because since there is no strong typing, that annoying strong typing that is inside the expression, you will never know if that is really good code that you are assembling together or not. That's a problem. You have more chances that something goes wrong at runtime in comparison to the code that you can write with the expressions. But Roslyn have a big advantage. Since the whole language is covered and you can write whatever you want, you can create types. And so the first reason to use the Roslyn compiler is that we want to create types on the fly. Let's say, for example, I want to create a DTO of an existing object on the fly without even using AutoMapper, because AutoMapper is something that you normally use at the development time, okay? And I want to use at runtime. I want to, on the fly, I don't care. I want to use the type that will be instructed at runtime in my application to filter events that comes from the field. And these events are of different type every single time. And if you want to specify an expression, you have to create an expression, but you have to deal with a type that represents this data. And if you want to deserialize, for example, this data, you have to create a DTO for that. So the first simple way to create code with Roslyn is the parser. So you have the API for the parser. You simply write some text and say, OK, let's go. I want to parse this stuff. I want to grab the syntax tree. And once you have the syntax tree, you have an entire world of API at your will. So you can reformat it so that it's nice to see because there is all the indentation. Okay? You may want to convert it in a different way. For example, you have refactoring API. You want to change the name of the variables. Or maybe you want to replace some call from the console write line to the console write. So you don't want to create everything from scratch. I want to read this, use as template, and then replace only a few things. And for this purpose, the visitor is very nice, because you can just visit some of the tokens that are inside your application. And then when you find the correct kind of token, you just replace it, and you are done. Formatting is as simple as you see in the slides. So many things are really very, very simple to do. And if you want to do more, you have the syntax generator. The syntax generator is something that is a high-level API abstraction. There is another, the syntax factory, that is below, but the syntax generator is really very powerful. We will see in a moment a few examples of this. And you can declare things. You can declare namespace, the class. You can create the attributes. You can declare the parameters, and then blah, blah, blah. You have the full-fledged language that you can use. And when you want to fix the spaces between the statements, you just call normalize with white space. And magically, the compiler understands that between one syntax node and another, maybe it's better to put a space, otherwise the toString method will represent the code very badly. Okay? Before going to this, I want to show you the first. Okay, we have a few samples just to show you how these things work. The first one is this mess. Let me, yeah. So you basically are using the syntax factory. We have the syntax trivia, the identifier qualified name, and the compilation unit, the using directive, and blah, blah, blah. You have all this stuff. And you say, oh my God, it's even worse than the expression trees. Okay, this is the low-level API. You know, it's important to know it because we have a nice tool, as I said before, I was going to show, that when you are out of the compiler, you install the SDK for Roslyn, and once you click here, you see here how the syntax tree of this specific source code is created. So you basically use this tool to learn how the nodes in Roslyn are put it together. And that's very important, because if you don't understand how to represent a call to a method, or how to represent a generic parameter, how to represent a return type or an integer, and you just go there and see how it's represented from the syntax tree visualizer. So this is a very powerful tool and can also create nice drawings and blah, blah, blah that I will let you to explore because we have a lot of other things to see. This is quite nice, okay? So I repeat the debug. I go there, and once you have the final syntax node, you basically have the source code. You should be able to avoid having the syntax, the source code and keeping only the syntax nodes, because of course when you compile you don't want to reparse again all the tree. But they are very useful for two reasons. The first is that there is no other way to specify the encoding. And so the compiler may screw up if it doesn't understand correctly the encoding of what is your source code. The second reason is that it's extremely precious to have the source code for debugging purposes. Even if you are in production, certain times it's better to keep for a while the source code of the code that has been generated, so that it's like a log. I mean, it's something that you may want to keep. Okay. The second one is very simple, is the one that was on the slide, and as you can imagine, is extremely simple. This is what I generated, and after the formatting, this is what I obtained from the formatter. So you don't have to bother. There are no more excuses to use the string builder anymore. You are, okay? Please, no more string builders to create code. There is another nice example that is this one, where I take the usual example, okay, but then I want to transform it with a post process that transform by using link to find the nodes that are of the type that I am looking for, basically. Okay? So I am willing to find certain nodes and to replace the nodes with some other. So you remember that there was the console write line, and I want to change with the write. And I simply find this node, and I replace the node with a new one that I created above. And then I want to find the square brackets block and put also a console read key. Okay, so I will put all this code right there. So at the very end, the transformed one will have the write and the read key right after. So you can slightly modify your code at your will. That's pretty cool. Not very difficult to do, but very powerful. And also, the final one is this one. I basically created the code generation helper as kind of high-level syntax that I created to make something more useful. So you can abstract yourself the syntax generator in order to be able to create a class, add properties, and so on. And this is one of the examples that it's worth. For example, to create a POCO or with as a DTO, for example, is very nice. Well, and now we have all the result of the demo. There is another very nice thing that I want to show you very quickly. That is this slightly more advanced generator. And I have a couple of these. So I love abstractions, like probably all of you. I mean, abstractions are the one who saves us in most of the cases, right? And when you have like a syntax generator that can do almost anything, you discover that it's pretty difficult to use, and you want just to restrict a little bit the things for your vertical use case, so that it's more simple to use. So I have two different things. The first is one that can just create properties, and I will show you with the test. The tests are quite boring for this. OK. It takes a while to load the test. And this is very powerful because I want to show you that it's possible to create an abstraction that gives you exactly what you expect from a DTO, for example. So you have just the properties with a class, very simple, that mimes the one that I gave as an input on the other side. So it's very useful. And the other one that is more complex is not here, but OK. I want to show you more advanced. I implemented it in my abstraction the add implementing iNotify property changed, so that when I go here and take the result, if I see the diagnostic report that I create after the compilation, you will see that we will have a full-fledged class implementing iNotify property changed, declaring the event, expressing the string name with the onProperty changed, and implementing the onProperty changed with the color member name as the manuals recommend us to do, OK? And that's pretty neat, I mean. And I will publish a few of the things that I show you on GitHub, of course, so that you can put your hands directly. And if you are wondering how all this magic is happening, of course, it requires a bit of code, because the code generation, the complete one, is very, I mean, you see, there are many classes, and they are simply wrapper for everything that can be done with a syntax generator. So I don't want to get boring you with all too many details, but we can discuss right after if you want. By the way, the simple one is really simple. I mean, you see the other project. There are just a few classes. This one is to generate the code. This I have to bring with me the references, for example, the system runtime. Since most of the code that I showed you is already running on .NET Core, by the way, and it can run in both .NET Framework and .NET Core. But I am a .NET Core lover, and so I prefer to show that. And then I have a dictionary of strings where I accumulate the information of the syntax nodes. And then when I call the get source internally, I build the class first. And this is basically adding to the nodes the class declaration. And then for every item in the dictionary, I project this to a create property that is creating a trivial property. And this is exactly the same code that I also put in the slides. So you will also see the create property for a trivial property in the slides. This is the property declaration, and the get a simple accessor. It looks quite verbose to be a trivial property. You may wonder why. The reason is very simple. Because normally the property have the backfield. And in order to specify being trivial, I have to remove a part of the code and replace with a simpler annotation. That is simply the why you see 3 lines for getting the accessor and then 3 for the set. That's nothing. There is not that much to worry with. And that's the most important part. I want to go back to the slide because I have another few things to say before closing. You see the syntax tree tool is the one you find inside the .NET compiler platform SDK. Okay? These are the examples that we just saw before. So the creation of a class with a property. This is the property declaration. And the demo, we have just seen that. So we have to spend the few minutes that are still there with the obvious question. So you're talking about generation, and why not IL? No? So what's the point? Had you imagined a session made with everything with the reflection emit and poking directly in memory and so on? So I have to say, I love assembler. I was born with the assembler. At the time that I began, I used the x86 assembly because it was needed. There was really, it made a huge difference between working with a variable in memory or with the registers. So you cannot rely on the compiler. It was not possible. But now everything is different. And if you really want to go to the assembly, there should be a strong reason for that. Okay? It's not just because we love to do the hard way. No? Okay. I am one of that, but manipulating the IL code is something that is indeed very, very useful. Because what about having a third-party DLL and you don't have any clue of what it's doing? So you take IL spy and you open that DLL and say, OK, let's see inside the code. And as you well know, you begin looking at the code and you say, OK, but what the heck is doing at runtime? I don't care about this blowout of tons of classes that are involved in this. So you have to imagine what happens during the runtime. And that's pretty bad to see. So you install the Visual Studio plugin of IL code that allows you to reflect the code on the fly and debug the stuff. And you see, yes, but you have to press F11 for everything. And after a couple of hours, you say, oh my God, what is going there? I don't want to mess up again with all this code and lose all my day just to see what the heck is doing this DLL. And so there are things that you may want to do automatically. After all, our work is to find a way to make the things in a sort of automatic way. Monosecil is very powerful and allows you to grab the instructions, to decompile them, but also you can filter them, you can watch them, you can analyze what's inside them. So you may see the arguments, you can distinguish between them. So I imagined a scenario, and there are many, because on the internet, on GitHub, there are many tools that are doing similar things, where I want to identify all the calls. And what if I monitor what is going to do a call? But instead of pressing F12 or F11 on each call during debugging time, I want to instrument that specific IL code so that I can create a sort of log of what it's doing. And that was the basic idea that I'm still working on, by the way, which is pretty simple. I mean, there is nothing that is so terrible. So basically, I have this sample one DLL that is here. You see, there is a data helper that simulates a call on a database. And then there is an employee, is a DTO. There is a person, OK? There is a printer that prints on the screen this stuff. And then a main, because a third-party application, this is a console application. And depending on the argument, it makes a start 1 or start 2. So the first is very simple. It's just print a person on the screen. And the other, instead, load all this stuff and then make a projection with the string, with the toList. And once we have the list of strings, it uses the print to output. And there are many things. Also because the for each that is used inside the toList, you know, trigger a lot of things. There is all the link internal stuff happening, so the enumerable and blah, blah, blah. So let's begin with the first one and see what happens. So I just run the application. I don't need to do anything else. And the good thing is that I run the assembly hooker that traps our DLL and do exactly what we have seen on the slide. So at this point, I can open Visual Studio Code, and this is the result. And the nice thing is that I have a bunch of logs that were created by the code that I injected inside this third-party DLL, which is a console, by the way, because of .NET Core. And I annotated with every kind of information I had in this moment. But since, do you know what it is, plant UML? It's a magic library that allows you to transform this strange dialect in this. And now we have the flow diagram happening at runtime. I mean, this was exactly what we executed at runtime. It's not something static analysis that maybe can go anywhere, and it's a nightmare to understand. This is our actual run, OK? And I believe that is extremely powerful. So you see, you can recognize when we set the values of the name and the age, and then after the write line, we have the get, and so on. And then, of course, each properties has been translated to string with the toString, and so on. And we have the actors here, the program, the person, the console. And I believe this is really amazing. There is another possibility that is quite a bit more complex. And if you are curious, just follow me right after the session. That allows you to track the other one. So basically, with the second option, we do a lot of things, you remember? OK? And what we have on this side, let me take this. OK? The log was updated by Visual Studio Code. I generate the diagram. And this is literally super useful. And you see also the enumerable. Okay? So you can even see what is happening inside the framework, basically. Because we just injected this stuff, and I didn't have any, even to write this stuff on disk. I just directly loaded in memory and executed on the fly. This is why you saw that call by reflection on the main. So this is basically the potential that I see in using DirectIL, not just to generate methods, which is pretty useless in my opinion, because you have better tools, but to modify the existing IL to do other things. My vision about code generation, probably the artificial intelligence. It can be pretty scaring, I admit. But I see that if we find a way to create a sort of contract of very, very small libraries that can generate the required code, and then when algorithms that are driven by artificial intelligence, potentially we have a very, very powerful machine that can automatically generate the code that is expected. What comes from this? I don't know. I am just investigating the field. If you are interested in investigating with me, come on. So, to sum up, I would say use the code generation to free the hot path, of course. Please do not write everything with code generation, because you know there is an important tool that I invite you to test, that is the Roslyn quoter, that is this one. And if you, for example, make a public string test get set and quote this stuff, you get the reverse engineering in Roslyn of what is needed to create that expression. Then I had a very weird idea. And what if I put this, I create and I go in a Stack Overflow of a code generation. That is terrible. Okay, so please stop me. Thank you very much for being here.